That simplifies to 3 times 3, which gives us the correct answer. As long as you're cool with pulling the 2 down into the denominator, and I contend that's completely legit, then this one's hard to argue with.
And then you get this guy who writes 6 divided by 2 over 1 over parentheses 1 plus 2. So this is where the confusion comes in with this question. If we move this under here, that's going to change the operations, because now we need to divide whatever happens here last. Now it's 1. Alright, so before, Dave is right, it is 9, but if you write it differently, you get different answers. It all depends on how you write your fractions.
We're going to go ahead and do this one more time and solve 6 divided by 2, 1 plus 2, and put it to rest once and for all. If you're writing it in code, this would be the correct way. 6 divided by 2 times 1 plus 2, with parentheses around the 6 and the 2 and the 1 and the 2. The other way would be assuming the 6 should go over the rest of the problem, turning it into a new problem. That would be 6 divided by parentheses 2 multiplied by parentheses 1 plus 2. The reason this is the correct way, 9, is let's go ahead and take a look at this in Visual Code. In Visual Code we have it set up here to divide 6 by 2, and then 1 plus 2, and then multiply, which is what we want to do, right? Simple enough. No parentheses, you can imagine them there, but you don't need to. It's 9. If we were to assume the 6 should be over the rest of the question, we would literally have to take this, watch. Now it's 1, because we divide last. Do you really think this is the right way? Like really, do you think this is the right way? You just implied it in your head this way. This is more complicated. Humans always make rules around making things simple. Why would we make it more complicated? Alright, 9 is the correct answer. Why? Because you don't divide last. See? 9. Ta-da! Thanks, and again, if you're a teacher and you're teaching this as 1, please retire, refund all of your students their money, and apologize to your dean for being a professor. Good. Alright, in my last video I was being polite, and this is for the one that people think the answer is 1, or think that order of operations has something to do with how you write a fraction, which it doesn't. And sorry, my mouse keeps scrolling up and down, it's broken. BODMAS and PEMDAS don't matter. The answer is 9, okay? Get that through your head. It's how you group the denominator in the parentheses, with the parentheses, okay? If you group the denominator with the parentheses, it is then 1. This is called implicit grouping. It is something you are doing implicitly, okay? If you use PEMDAS or BODMAS or PEMJAS, where is it? PEMJAS, you get 9, okay? The answer is 9. I didn't think I had to say it meanly, but the answer is 9. Since many of you still don't get this, 6 divided by 2, 1 plus 2. Okay? Doesn't matter whether we use PEMDAS or PEMJAS or BODMAS. The MD and the DM are done left to right at same time. Big deal here, right? Because it doesn't change no matter what the acronym is, okay? You don't divide last here, and here's why. You don't assume the 6 goes over this, right? We don't assume that you put 6 over this question. That changes it to a new question and makes it 1. When you use PEMDAS, you do left to right, or BODMAS, PEMJAS, whatever you want to call it, left to right at same time, okay? Now, let's do this. This is 3, parentheses. Now we need to divide left to right at the same time. So we're going to start with division regardless of using BODMAS or PEMJAS, because we go left to right at the same time with both MD or DM. Okay? Now it's 3, okay? Now we multiply, and it equals 9. I almost said divide there. No, you would divide if you didn't understand what was going on, and you wanted to put 6 over this and turn it into a new question. This is very simple to understand. If you're going by order of operations and how it is written, which is left to right, it's 9. And if you're still confused somehow, these two questions are the same. We're going left to right operations here. These are the same question. As I demonstrated in my fraction calculator, when you write 6 over 2, 1 plus 2. And for those arguing ambiguity, this is ambiguous. You can look at it either way, but the right way to look at it is with left and right. Why do we look at this as a left and right question, either of these? Because they are written in a way that asks us to solve left to right. This question asks us to solve this question first, and then solve this question. Now we have to use left to right order of operations on this part of the question, and then solve the rest of the question. Does that make sense? If the question was written like this, it would make sense for the answer to be 1. If the question is written like either of these, the answer to the question now makes sense to be 9. Again, I can explain this as many times as you guys want, but it matters how you write it. There is ambiguity, but the ambiguity is in how you write the fraction, okay? So if we want to use all sorts of logic here, we're going to use left to right because the string, the actual question itself that is written in a string, if we're using code, is going to solve it left to right, unless we tell the compiler otherwise or write it like this in a language that accepts this format. Does that make sense? So when you're programming, there is a correct answer to this, but the question itself is ambiguous. It is 9 or 1. But really, it's 9 because it's written left to right. Hopefully this will be my final video. Who's got it right? The right way to teach math, or maths. Okay, so this is how, I need to stress this enough before we start. Traditional math is the same no matter what country you're in. Non-traditional math, depending on what type you're learning or teaching, is the same no matter what country you're in. This is why people in the United Kingdom do not understand that 6 divided by 2 parentheses 1 plus 2 equals 9 in traditional math, and they want to keep arguing it with you. In the United States, you're taught Algebra 1, Geometry, Algebra 2, Trig, Pre-Calc, etc. In the United Kingdom, you're taught math, 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 math. You're not taught that there's any difference between traditional and non-traditional math. So, who is right? It must be so boring for kids to do all the same topic all year. No, not really. It must be so confusing for kids to jump topics constantly. No, not really. See? There's benefits to both of these things. The problem is understanding the difference. But American students will have a broken and fragmented view of maths, Perl. They'll see only partitions and subcategories, not coherent whole. They'll never glimpse that the unity of maths never connect the dots. This is actually true. There's a lot of Americans that do not understand there are 2 or more types of math. You can tell any American that there is more than one type of math, and, well, not any, but a good 95% of them will argue that there is only one type of math, and that is the traditional math they were taught. The American idea is no, British students will not have a broken, fragmented view of math. They will see only an underreferential sludge you got to reckon with, and subfields, and the subfields individually before you can appreciate their relations. So basically what they're saying here is, no, you're going to start just doing whatever you want, implying different things to different questions. So if we were to look at the question one more time, 6 divided by 2, 1 plus 2, and we use traditional math, which I can't stress this enough. Traditional math doesn't change. It's not like English tradition or United Kingdom tradition. It's universal, it's global, it's traditional math. The traditional math we use in the United States and use in the United Kingdom will be absolutely the same as if you go to any other country like China, Japan, or Australia. This traditional math does not change. This is why in grade school, Americans are only taught traditional math. And we learn higher math when we go to college. This is so we do not form some sort of weird ideology that math is taught differently in different countries. Because while it is taught differently, the classes you take are taught differently. They're not named and they're not categorized right in the United Kingdom, apparently. And they just want you to go straight from traditional to high level. This is why we teach traditional math in the United States, and this is why the United Kingdom people keep thinking it is one, and they keep telling you, well, it's because I learned BODMAS or something. No, that's not true. You were just taught math all over the place. You didn't learn traditional math first. You learned high-level math with traditional, with high-level, low-level, with traditional, with all sorts of, you were taught every sort of different way to understand math other than the traditional way. That's problematic, and that's why the United States teaches traditional math in grade school. Okay? All right? See ya.